Hello and welcome to day 18 of Advent of Code. We're getting into the final stretch now. I've had a lot of interesting problems so far. It's been a day or two since I've finished in the top 100, but tonight's a new night. There's some great apartment music going on right now, and let's see what day 18's got for us. A tablet, assembly code. All right, this seems like fun. Plays a sound. Okay. Okay. Recover the frequency of the last sound. What's the value of the last recovered frequency given the puzzle input? Okay, so seems like we have a few different kinds of instructions here. Let's see what we're working with so far. All right, so the recover operation, I see. Okay. So it seems like there are registers that are named by, all right, plays a sound, recovers the frequency, but only if the value of X is not 0. Okay. All right, so yeah, let's start implementing this. So some kind of step with a state and an instruction here. The instruction consists of maybe like the instruction and then some values A and B. And then we already have this in our thing here. So basically, based on the instruction here, let's see if we do something like the set of map first. Okay, and it doesn't like that I didn't finish this up here. Slurp, regular slurp. All right, so let's talk about these. All right, so it looks like a jump instruction. Jumps with an offset of the value of y, but only if the value of x is greater than 0. So this is a register thing. Okay, so let's talk about the register thing here. So our state, so this doesn't look like a self-modifying thing. So let's just say that our state consists of the program counter, and the registers. Okay, so in this case, the the program isn't going to change, and then the program counter is going to say something like, if the registers at A is greater than 0, then the program counter is going to be incremented by the offset. Okay, so let's say we'll increment the PC by, so I think we do have to read this as a number. Otherwise, I think we just have to increment the program counter. Okay, and then let's see, the registers don't change in this case. All right, and SND plays a sound. All right, so maybe we want to have something like the sounds here. And we just basically want to conjoin onto the sounds the value here in A. All right. Okay, so then we have our add increases register by the value of, okay. Okay, so then similarly, actually we probably want to have like a structure like this. Okay, but then in this case, we really just want to increment the program counter. All right, now add is going to take this structure here Also increment the program counter. Leave the sounds the same, but then the registers are going to update the registers with add by read stir. So like this here. So this should be pretty good. I think there's a fnil which protects us from nil a little bit here. All right, and then looks like mul works much the same way. Okay, and then the multiplicative identity is 1. To the remainder, okay, so that should also be fairly straightforward here. Dividing the value in register X by the value of Y. Okay, so here we're talking about using rem, and I think I'm going to assume that the value in this register is always going to be defined. Oh, by the value of, oh yes, it is going to be always defined. Okay. Okay, and then we have recovers. All right. So there's our, all right, and then I think this is one of our last ones here. RCV, and then we know that the answer here, last value recovered. So we might do something that's a little bit cheating here, but just def the answer to be something like pop from the sounds, like this. All right, increment the program counter. Don't change anything about the contents of the registers. And then let's see, so that's recover, mod, mul, add, and then let's see, we also have sets value in registers to a certain value. Okay, so that should be pretty straightforward. I think we can probably just copy like we have here, the set instruction, and we're just doing an associate. Yeah, this looks pretty good. All right. And yeah, so let's say that we want to basically reduce the step starting with, let's see, so what's our starting state? So the program and then 0. Okay, so it seems like the program counter. All right, so this part needs to probably come out. And then we say this is in the program look up the value by the program counter. Okay. And then if the program counter is in the range of this to, I guess, 1 more than the count of the program, so this can, so 0 can be less than it. Otherwise, I think we're basically talking about returning something like reduced of the sounds, let's just say. All right. Too few arguments to if it's complaining about. Okay. All right, looks good. And then reduce step, starting with the program counter is 0, The registers are an empty list. The sounds is an empty list here. So there's our state. So where are we using where are we using registers here? So okay, we're using registers. Ooh, okay. So the second argument here says something. Okay, so then this read string, I'm going to change to read reg. And this is just basically going to take the registers in here, and it's going to be aware of the fact that registers might be 0. Okay, so then our implementation is that if these are our registers, and this is our value v, if v is a number, then just return v by itself. Otherwise, look up v in reg, and if it isn't there, return 0. Okay, okay. All right, and now we're doing a reduce by range. Let's give this a try. Wrong numbers of args passed a step. Oh, right, we want to pass in this n value, which is not used anywhere. Okay. All right, and somewhere there's a problem with. All right, doing a greater than. Check. Let's see. So my guess is here. Oh, okay. Yep, we can just change this to maybe like just a read reg on regs like this. That should be fine. Index out of bounds. Okay, okay. Nth in step. Okay, my guess is that that's something like here. Is this ink wrong? Give it a try. Okay, so that doesn't seem like that was the problem. Let's see. Let's see. So this is doing a greater than check. Nope, is it? Let's see. Array 4. Persistent array invoke. Let's see. All right, so I guess a good question is how many steps in are we getting? Okay, so this looks like in the first case, like something's working, so that's good. Okay. All right. Seems like that also worked. Okay. All right. Okay. Huh. Okay, so this seems like it's playing a bunch of notes, Okay, maybe we should use a def. Okay. Okay. All right. So when we're talking about the state of the machine, we're talking about this here. Okay. All right. So this seems like it's just done working. So in this case, what is the answer? Def answer to be pop. Probably peak. It's actually probably more appropriate here. Oops. Okay. Like this. A, value of the recovered frequency most recently played sound. The first time receive instruction is executed with a non-zero value. Ah, okay. So in that case, it does seem like the answer is B. All right, but that answer appears to be wrong. Okay. So maybe when a receive happens, we want to do something like PRN, like this. Okay, so based on this, it does seem like the answer is B, and I think, didn't we say B? I did guess B. What's the value of the recovered frequency? Okay. Well, so here we go. After each jump instruction, program continues with the instruction to which the jump jumped. Okay, next instruction. All right. All right, so I still don't like how we're getting the index out of bounds exception. It seems like if this value is, so if the count of the program is 0, I see, this actually has to be one less than it. Okay. Okay. Uh-huh. Okay, and then, so recover the value. Oh, I see. Okay, so it seems like send needs to be read registers like this here. And then our recover operation needs to be something like value most recently played sound. The first sound. Okay, so then we need to say something like, let's take a look at what a recover operation looks like. B, A, B. Okay, so we want to say basically like if greater the value of X. Okay, so if greater than read regs A is greater than 0, then print out this thing here. All right, and then try this. All right, and then it doesn't print anything out. So that's not very helpful. Okay. So, all right, let's see how this works. So, all right, this one at least is printing out some values, although it appears to be printing out a lot of values. So it seems like I probably screwed something up. First 4 instructions, okay, set itself to some value modulo some other value. All right, this is still stuck printing stuff out. Okay, I'll just close this. Okay, so all right, so what if I only take 5 here? Okay. All right, so this is saying set A to 1 and add 2 to it. All right, so this is setting A to 1. It does add 2 to it. Set it to itself modulo square it. Mul AA. Okay. What is the problem here? So this is saying, oh, okay. Yeah, all right. So mul actually needs to be this. And then that needs to be that. Uh-huh. Uh-huh. Okay. Square it. All right. Taking one more. Setting it to 4. Okay. Now it is getting to this part, but it's saying that no sounds have been played. Right. That the list of sounds that have been played is just a list containing 1. All right, I mean, we can try 1, but it does seem like we're missing something. So, all right, then a sound with frequency, with a certain frequency is played. Okay, so after that, A is set back, finally, which ultimately triggers the recover instruction on the frequency of 4. Okay. All right, what is the value of the recovered frequency the first time a recover instruction is played? Well, according to this, when I run it, it says nil. So that would seem to imply 0. Hmm. Hmm. Yeah, something doesn't seem quite right here. If, let's see, so if the value is, then print peak at sounds. So we're doing a recover here. So in other words, we said like this, and then we said here, and what it's saying is that no recover is actually succeeding until, actually it says no recover really ever succeeds. Hmm. Well, okay. Everything seems to be increasing the program counter. This seems to be behaving in the right way. Time the recover operation is executed. Frequency of the last played sound is 4. I mean, we can try the value 1, but that's not the right answer. Yeah. Oh, forgot to take that print line out. All right, and in this situation, yeah, the only time this recover succeeds is a situation where sounds is nil. Um, Huh. Okay, well, let's take a look at the program, which, as far as we know, behaves properly. So we have set add mul mod send sound recover ggz jgz. Hmm. Hmm. Maybe we should take a look at program. All right. Seems to be pretty straightforward here. Maybe what we got to do is return this whole thing. All right. So this is saying all the registers have a value of 0. Yeah, this does seem to be consistent with us screwing up some nil value here. Maybe f nil. Maybe this is wrong. Maybe this needs to be like this. Here. Well, this seems a little bit more promising, I guess. Let's take the PRN out. And yeah, let's see at least if we can get this thing to return. Okay, looks like that change didn't quite take effect here. All right. Okay. All right, I mean, I guess we can try 7071. All right, so that was the right answer. Let's go back to day 18. Okay, part 2. Job well done. It's meant to run twice at the same time. Each running copy of the program has its own set of registers and follows the code independently. To coordinate, they use the send and receive instructions. Send sends the value of X to the other program. Okay, a program can never receive a message that is sent. Receive receives the next value. If no values are in the queue, then the program blocks. Okay, each program has its own ID. The register P should begin with this value. Okay, so both programs begin by sending 3 values to each other. All right. Okay, and then they terminate on deadlock. Uh-huh. Okay, regardless of what. Okay, all right, fun. Fun, really fun. Okay. So, all right, so we got 2 programs. They both have their own program counters here. All right, so how are we going to do this? I suppose we're going to have the program have a queue. Seems pretty good to me. The receive queue and the send queue. And send is going to, okay, send is easy because we just do a swap bang on the send queue, adding in this value. Okay, and then I think that's fine. I guess we got to wrap this in and do. All right, and then receive is going to be basically receive a value from receiving queue. Wonder if I can figure out how to use a channel for this. Let's see. Java linked blocking queue. All right, let's take this here. Chrome is not really cooperating with my Control C here. It's funny. I wonder what this is. This should copy something to the clipboard, but I see. I guess the developer mode had something to do with that. Okay, so if I have a linked blocking queue here, what are the operations that are supported on this? Looks like there's a poll, a peek, put, take. Okay, so I think we want take. So basically, if we're doing a receive, okay, so receive means pull something in from a queue and put it into that value. So we basically call take from the receiving queue like this. Okay. And then we want to do an associate in the registers the value in A with V, like that. Okay, looks pretty good. And then in order to put values onto the queue, we're not going to use swap bang. We're going to use offer. That looks good. Okay, so offer onto the sending queue, whatever value is in here right now. And then the question that's asking, how many times did program 1 send a value? Okay, so maybe this also needs to have an ID. And then something like sends being an atom 0010, like this. And then under send, we're going to say swap bang sends update ID increment. This. Okay, not expecting this to take a lot of time because it seems like there's not a whole lot for it to think about. Okay. All right. Okay. Now we need to basically run 2 programs at the same time. So the 2 states that we want to start in are pretty much let the program be this thing. And then, I don't know, I think you can call it run on thread dot, passing it in a function. And then that function is just like reduce starting with 0 program program counter 0, register like this, sends like this, and then needs a send queue and receive queue. All right, so we'll say Q1 is one of these. Q2 is another one of these. And then we'll just say Q1, Q2. Right, working off of the whole range of numbers here. Working off of the step function. Called the step, right? Yep. Okay, and then like this. And then I think there's a way to like join these, but as it is, I'm just going to return them as will this work? Oh, I'm using a future just in case. And then we can use our future done on F. Okay, so this is usually, yeah. All right, so what's up? Okay, this is saying, yep. Count isn't supported on a long. Well, okay, so in the first case, I do know this needs to be like that. Okay. Count is still not supported on a long. Let's see, so ID program counter, okay. All right, we're checking the count on something, maybe right here. Seems like a reasonable case of doing it. Okay, but this all seems fine. Let's try this. Okay, same problem. And saying, okay. Let's just do this. See if we can bottom this out. Okay, oh, I know what the problem is. We added a program ID in here, but then every implementation of all the functions needs to support it. So there. Oh, not only that, it also needs to support the, yeah, it also needs to support the receive queue and the send queue. Okay. Well, it's not an infinite amount of work, I suppose. Okay. Like this, 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 and this. All right. Okay. All right. Good. Very good. Very good. Okay. So here we go. How many times did program one send a value? So we have something called the sends. Okay. Okay. This seems to be implying that program one sends 0 values. And you know, that's probably not the case. Guess we can take a look at send here. I mean, maybe are they called 0 and 1 or 1 and 2? Both? Okay. Okay. How many times did program one send a value? Well, this is telling me that program one sent a value 0 times. Wait a second. So if program one, oh, I see, because it was, yeah, because it was set that way. I don't know. I don't know. I think there's a future cancel. Okay, so let's try resetting this value maybe. Going up here, doing one of these. Okay, so this is running. Okay, sent into the same state. I mean, I can try 0, but yeah, I mean, I don't understand why one program would send so many values and the other one wouldn't do anything at all. Oh, yes, I do. Oops, no, that's not how we do this. Cancel. This needs to be actually Q2, Q1, like this. Okay. Nope. Oh, future cancel again. I need to reset these values up at the top. Okay, good. There. All right. All right. Now let's see what we've got. Same deal. Okay. This is not promising. Okay, so we have the two queues. Let's see. Here's the receiving queue. It is fortunately offering the thing on the send queue. All right. We do something like this just to verify that programs are in fact running concurrently. Okay, seems like they're not. All right. Um, hmm. Well, am I misunderstanding Java thread? Maybe run means, yeah, probably. Probably there's something besides run that means sort of like launch and, well, let's take a look. Run. Otherwise, okay, yeah, that doesn't seem right. I want, okay, yeah, start. Seems like the more appropriate thing here. All right. Okay. This seems like it finished. And then what happens if we say sends? Okay, so that's actually a reasonable answer. Let's try it again. Okay. All right, so it says, okay, so it's still cranking. Okay, so this seems like a lot more reasonable. And the reason that future done returned is that it actually did launch these, and It's not waiting for these threads to join back. Okay, so I think as long as our implementation is correct, we only have to just sort of examine this for a little while until it seems like it's deadlocked. It seems like it's deadlocked. So how many times a program? 1, send a value. Not the right answer. All right. So I guess I don't know that the threads are deadlocked. There's a way that I could check for that. I could have, like, say, an atom called like blocks, set this to 0, and then in the receive here, I could basically do like a swap bang blocks increment followed by swap bang blocks decrement. And then if this ever reaches 2, then I know that the program is deadlocked. But yeah, I mean, so I guess, how do I kill these threads? Wait for it to come up. Okay. All right. So yeah, everything here should be pretty doable. I'm going to ignore this stuff. And yeah, I reckon I can probably run this whole thing. All right, take a look. Oh, long can't be cast to a future. This should have, okay. Long can't be cast to a future? Oh, right. Okay, yep. Uh-huh. Okay, don't know how to recover from this situation. Futures have already been started. We'll probably figure something out. Or I can just restart the REPL. All right, let's see here. All right. Let's get this whole thing going. Okay. All right. So, okay. So it says it is blocked right now. So we have an answer. Not the right answer, though. Interesting. How many times did program 1 send a value? Huh. Well, I mean, I'm not surprised that the sends aren't changing because blocks is stuck. Basically, yeah, we have some threads. Each of the threads is waiting on. Yeah, they're each waiting on a particular queue. Yeah, if we reset this and we reset this, then we'd expect nothing to be changing here. And then, yeah, if we launch this again, then I'd expect it to produce the same answer. Same answer. Yeah. Hmm. Both threads are blocking. Okay, maybe I need to double check the problem here. So I guess we could try it with this. Okay. Uh-huh. Okay, well, 3 seems to be each program now sees a different value in its own. Oh, right. I forgot a part here. Basically, the register P should begin with this value. Okay, so P needs to have 0, and then here P needs to have 1. Okay. All right, so let's reset this value, run this again. Blocks is 2. Look at sends. Okay, we got a new value here. Answer, rank 167. Okay, yeah, let's take a look at the leaderboard here. So seems like so both stars took me 51 minutes. Oh, if I'd only been 10 minutes faster, then we would have got the answer there. So and then yeah, it looks like first star was first star was a much faster affair. Okay, cool. Let's talk about the problem a little bit. So yeah, going back to day 18. Yeah, basically, this is similar to a lot of previous problems in that you have a program with a piece of machine code. You have need to keep track of the program counter because there are jump instructions involved here, and then there are just a bunch of other kinds of instructions that you need to be able to support. Let's see. The trick of the first part is that there are these send and receive instructions, and the semantics in the first part are that the receive instruction is actually a recover instruction, and it says you're going to get the last value that was sent as long as this register was not 0 or greater than 0. So yeah, they're kind of just like basically setting up for a multi-threaded program. And yeah, I had some bugs in my initial implementation, and that's just basically why I was slow to the final answer. But a pretty straightforward part 1, and then in part 2, you had to run 2 copies of the program at the same time. And in Java/Clojure, this is actually a fairly straightforward thing to use. You just need a piece of coordination between the 2 threads. So I chose to use a linked blocking queue. But really, any kind of blocking queue will do. Basically, you need to have the sending thread call just like an offer. Basically, take the value and say this is going to be the next thing on the queue here. And then because the output of the program depends on it, we also increment an answer variable. And then yeah, to receive a value, you just call the take method, and this is going to block if the queue is empty. So it's going to give the other program a chance to catch up, basically. So yeah, that's pretty straightforward stuff. And then what I'm doing here with these swap on blocks is I'm just keeping track of how many threads are blocking. any given time so that I can be certain that the programs are actually deadlocked. And then I can just call this get the value of sends out here and get the answer. So yeah, pretty straightforward problem. The main place where I got stuck, I think, was around the fact that the program needed to have a piece of it needed to have its program ID set in the register P here. So I missed that for a while, and so that was a big deal. Another big deal is that I was calling the wrong method to start the thread. I was calling run instead of start. So run is basically run this thread and block until it finishes, whereas start is launch this as a new thread. So yeah, I needed to get that clarification. The behavior that I was seeing before I had done that was basically that the second program wasn't doing anything. So that should have been a tip off to me that nothing was, yeah, that basically the first thread was executing and that the second one wasn't. So yeah, pretty fun problem, pretty fun night. Yeah, take a look at our calendar. You can see that I'm actually missing a day. Still need to go back in and finish up on the dancers, but that shouldn't be too difficult. And yeah, looks like we got 7 days left till Christmas. So so pretty exciting. We're getting into the final stretch here. If I look at the leaderboard, it tells me that that 100th place is 539 points, and if I look at I see that I have 300. So yeah, to get onto the leaderboard in a single night would be tough, but a couple good nights in a row, and who knows. So yeah, just got to practice, get organized, try not to make mistakes, and take it from there. So I'll be back at it tomorrow. I may have a chance to post my solution for part 2 of day 16 in the meantime. But if not, then I will just see you in tomorrow's broadcast. Thanks for watching.